Welcome back sa ating lesson number 3 for EE1DC circuits. The part 2 of the introduction to electrical circuits. So we will be discussing for this lesson electrical power and energy. Once again, I am Engineer Christian Averion. For part 1, we have electrical power. Power, or P, in an electrical circuit is given by the product of potential difference V. Again, PD is potential difference and potential difference is voltage. And current I. As stated in the previous lessons, the unit of power is the watt. Hence, P is equals to VI, P is equals to I squared R, and another formula is P is equals to V squared over R. So, these are the formulas for power. So, pakitandaan itong mga formulas na to. The most commonly used formula for power is this one, the P is equals to VI. And these two are derived from Ohm's law. So, yan. So, hindi ko na di-discuss yung derivation, but doon siya nakuha sa Ohm's law. So, P is equals to I squared R and P is equals to V squared over R. So, kung mapapansin natin, the unit for power is watt. We can mostly hear this as a power consumption ng ating mga appliances. So, let's say, ang isang refrigerator have a 1,000 watt power rating, electric fan, let's say 500 watts. That is the power consumption of the appliance. So, pagdating natin dun sa ating next chapter, yung next lesson, yung energy. So, dun yung makikita kung paano gumagana yung ating, yung sinasabi natin na watt hour or yung kilowatt hour or yung power consumption natin sa ating mga bahay. So, as of now, dito muna tayo sa electrical power. So, let's proceed para sa ating problem number 1. A 100 watt electric light bulb. Again, yung watt is yung power rating ng ating mga appliances. So, in this case, electric light bulb yung ating hinahanapan. Let's continue. A 100 watt electric light bulb is connected to a 250 volt supply. Determine A, the current flowing in the bulb, and B, the resistance of the bulb. So we have P, 100 watts, and we are looking for the current, which is I. So we have P and V, and our formula for power is P is equals to VI. We are looking for I. So I is equals to P over B. And we have 100 watts over 250 volts. And the answer is 0.4 amperes. Next, letter B, the resistance of the bulb. We have V and we have I, so we can use Ohm's law. So R is equals to V over I. And V is 250 volts. And I is equals to 0.4 amperes. And the resistance should be 625 ohms. And that's the answer for problem number 1. As simple as that. So we will be using Ohm's law from time to time. And it will be the mostly used formula dito sa ating mga topics na to. Problem number 2. Calculate the power dissipated when a current of 4 milliamperes flows through a resistance of 5 kilo ohms. So we are looking for the current. We are looking for the power dissipated. And we have a current of 4 milliamperes and the resistance of 5 kilo ohms. And the second formula for power is I squared R. And we have I of 4 milliamperes. Let's convert. 4 times 10 raised to negative 3 amperes and R of 5 times 10 raised to 3 ohms. Ampere, ohms, so pwede na natin siyang i-multiply. Then the power will be 4 times 10 raised to negative 3 amperes multiplied by 5 times 10 raised to 3 ohms is equals to 0.08 watts. And that is the power dissipated. Next sample problem number 3. An electric kettle has a resistance of 30 ohms. R is equals to 30 ohms. What current will flow when it is connected to a 240 volt supply? We are looking for the current. So letter E natin is we are looking for the current if it is connected to a 240 volt supply. So we will need to get I is missing and the voltage is 240 volts. Ohm's law. I is equals to V over R. And V is 240 volts and R is 30 ohms. Our I should be 240 divided by 30 is 8 amperes. That is the current that will flow in our circuit. Now, we need to find also the power rating of the kettle. Power rating is P is equals to V times I. And V is 240 volts multiplied by the I of 8 amperes. And our power should be 1920 watts or also equals to 1.92 kilowatts. Simple. Okay, then let's proceed for problem number 4. A current of 5 amperes flows in the winding of an electric motor. The resistance of the winding being 100 ohms. Determine A, the PD across the winding, and D, the power dissipated by the coil. What are the givens? We have I of 5 amperes and resistance of 100 ohms. We are looking for A, PD or the voltage, and for letter B, we are looking for the power dissipated. So let's start letter A. V is equals to I times R. And I is equals to 5 amperes multiplied by 100 ohms. And V is equals to 5 times 100, 500 volts. That is the answer for letter A. And for letter B, let's use this two. So P is equals to I squared R. So we can use the other formula such as the P is equals to V times I. And let's use this one since ito yung mga givens natin. P is equals to I squared R or I of 5 amperes squared multiplied by R. R is 100 ohms. And P is equals to 2,500 watts or 2.5 kilowatts. That is the answer for letter B. Now let's proceed with problem number 5. There should be 80 here. The hot resistance of 240 volt filament lamp is 960 ohms. Find the current taken by the lamp and its power rating. We need to find the current and the power rating. The givens are voltage, 240 volts, and resistance of 960 ohms. Let's find I. I from Ohm's law is equals to V over R. Again, paulit-ulit lang halos to. So, you need to practice para hindi nyo siya kailangan sa uluhin. So, kailangan nyo siyang malaman by heart para mas madalian kayo. So, V over R. V is equals to 240 volts over by R, 960 ohms. And 240 divided by 960 is 0.25 amperes. Then for letter B, power rating, P is equals to V times I. And V is equals to 240 volts. 240 volts multiplied by I of 0.25 amperes. 240 times 0.25 is equals to 60 watts. And that is our answer. So let's proceed for the next topic. So we have here electrical energy. And electrical energy is power multiplied by time. If the power is measured in watts and the time is in seconds, then the unit of energy is watt-second or joules. Again, 1 second is joules. So if the power is measured in kilowatts and the time in hours, when the unit of energy is kilowatt hours, often called as the unit of electricity. Yun. The kilowatt hour na madalas nating nakikita at naririnig is the unit of electricity. That is how we measure electricity. So the electric meter in the home records the number of kilowatt hours used and is thus an energy meter. So yung mga metro, yung tinatawag nating metro, it is an example of an energy meter. It measures the unit of electricity which is in kilowatt hours. So let's have some sample problems para sa ating electrical energy. Again, kung mapapansin nyo, we are solving a lot of problems because that is the key para madalian kayo or para hindi na kayo mahirapan in the future. So solving a lot of problems will definitely help you in the future. So let's continue with problem number 6. A 12-volt battery is connected across a load having a resistance of 40 ohms. Determine the current flowing in the load. We need to find the current flowing in the load, the power consumed, and the energy dissipated in 2 minutes. So we need to find 3 parameters. We need to find the current, we need to find the power consumed, and the energy dissipated. What are the givens? We have voltage of 12 volts, resistance of 40 ohms, and that's all. So for letter A, we need to find the current. And current is equals to V over R. And V is equals to 12 volts over 40 ohms. Our current is 0.3 amperes. And for letter B, power consumed. So power is V times I. And V is equals to 12 volts. And I is equals to 0.3 amperes. Our power consumed is 12 times 0.3 is equals to 3.6 watts. And for letter C, the energy dissipated in 2 minutes. So again, energy is equals to power multiplied by time. So our power is 3.6 watts and our time should be in seconds. Again, This is a SI unit, and and energy is equals to power times time if the power is in watts and the time is in seconds. So we need to convert the time in seconds. So 2 minutes is equals to 120 seconds. And the energy should be equals to 432 watt seconds or 432 joules. So that is the answer. Okay, let's proceed for problem number 7. A source of EMF of 15 volts supplies a current of 2 amperes for 6 minutes. How much energy is provided in this time? Our givens are voltage. Again, another term for voltage is source of EMF. So we have source of EMF and potential difference. So V is equals to 15 volts and the current is 2 amperes. And time is equals to 6 minutes. How much energy is provided in this time? Again, energy is equals to power multiplied by time. First, we need to find the power. And power is equals to I times V, or V times I is equals to 15 volts and 2 amperes. And our power is equals to 30 watts. That is our power. But we are looking for the energy. And energy is, if our power is in watts, and time should be in seconds. So, energy is equals to 30 watts times time in seconds. So, 6 times 60. Energy is equals to 10,800 watt seconds or 10.8 kilojoules. So that is our answer for problem number 7. So last problem para sa ating lesson. Problem number 8. An electrical equipment in an office takes current of 13 amperes from a 240 volt supply. Estimate the cost per week of electricity if the equipment is used for 30 hours each week and 1 kilowatt hour of energy costs 13.56 cents. First, let's list down the givens. We have I of 13 amperes, voltage of 240 volts, and the time is 30 hours, and the energy cost is 1 kilowatt hour is equals to 13.56 cents. First, we need to find the power. The power consumed by the electrical equipment. So, power is equals to current times voltage is equals to 13 amperes multiplied by 240 volts. And our power should be around 3.12 kilowatts. And that is our power. And energy used is, since we need to find the energy used in kilowatt hour, the time should be in hour and the unit of power should be in kilowatt. Since our power since our unit in power is in kilowatt, we just need the time to be in hours, which is also in hours now. Okay? So, no conversion needed. So, let's find the energy used. equals to power 3.12 kilowatt times 30 hours. And our energy is equals to 93.6 kilowatt hour. This is the energy used. 93.6 kilowatt hour. Since we need to find the cost, we need to multiply 93.6 kilowatt hour to 13.56 cents because it is the cost of 1 kilowatt hour of energy. So total cost is equals to the total energy gain, the total energy consumed, which is 93.6 kilowatt hour multiplied by 13.56 cents. And the total cost should be around 1,269.22 cents. That is the estimated cost of the electrical equipment per week. Okay, that's all of the sample problems sa ating lesson number 3. And as always, I have prepared here a practice exercises again. After watching this video, please answer these exercises to practice to help you polish your skills in solving problems. It will definitely help you in the future. Again, to get a copy of this PowerPoint, just follow the description, the instructions in the description para maipasa ko sa inyo itong mga PowerPoints na to. So, this will be the end para sa ating lesson number 3. See you on our lesson number 4.